Okay, welcome to our first math lesson for math the year 2021. Hopefully be better than 2020. I'm recording this on January the 31st, so hindsight I guess will soon be 2020. All jokes aside. The concept that we'll be continuing with, and I hope that you have gotten all the other work done, previous work done. It's critical to get that done before you move on to this concept. Polynomials, again, a polynomial is a set of terms that it can be 1 term, 2 term, 3 terms, or even 4 terms. Okay, it's simply a combination of terms is a polynomial of the form x squared plus bx plus c. So in this lesson we'll be dealing with polynomials that have 3 terms. Now there will be some hands-on stuff that's built into this lesson, but I'm simply going to focus on doing this math with pencil and paper. If you pay attention, if you do all the examples that I show you, and if you do all of the assigned homework, then you will be able to do this math. Okay, so let's have a look first of all on this. This is on page, sorry I forgot to say that, this is on page 159. Okay, page 159. Now let's move down below the title here. And here we have c plus 3 multiplied, whenever you see brackets and there isn't a sign, you're multiplying, right? C plus 3 multiplied by c plus 7 gives us c squared plus 10c plus 21. Now, how the heck did we get that? Well, turns out there's a simple method that we use. And I'm going to introduce that method right now. So, sharpen up your pencils. Let's do a heading here first. Copied right from the book, but just so that you keep your notebooks organized. Polynomials of the form x squared plus bx plus c. We're going to start with c plus 3 multiplied by c plus 7. And we're going to use a method to do this math known as the FOIL method. F-O-I-L, FOIL. F stands for front. O stands for outside. I stands for inside. And F stands for left over. Now let's say I was doing this. Let's say I was multiplying 8 plus 4, add 7 plus 3. Okay? Can use this method with regular numbers to ensure that I'm multiplying each number by every other number. So my front terms, the front of each bracket, the ones that come first, are the 8 and the 7. See that? So 8 times 7 is 56. The inside terms are the ones, the outside terms are the other ones, the 4 and the 3. And 4 times 3 is 12. The inside terms are in here, the 4 and the 7. 4 times 7 is 28. Now, which 2 terms have I not multiplied by each other yet? Take a good look and you'll see it's the 8 and the 3. So it's the front term from this bracket and the outside term from this bracket are my leftover terms. 8 times 3 is 24. And now I can combine like terms. I'll just do that mentally. There's no, of course, there were no variables here, just numbers. So they're all like terms. So 56 add 12 is 68. 68 add 28, 78, 88, 96. 96 add 24 is 120. That's just illustrating the FOIL method using regular numbers. Now let's get back to C add 3 multiplied by C add 7. Let's put them here. My front terms, front comes first, are the two C's. C times C equals C squared. It's just like saying 2 squared is the same as 2 times 2, or 4 squared is the same as 4 times 4. So if I'm doing C times C, I get C squared. The outside terms in this case are 3 and the 7. The two terms, 3 times 7, there's no variables involved in this one, equals 21. The inside terms, right here, 3C. So that simply becomes 3 times C becomes 3C. And my two terms, my leftover terms, are the C and the 7. So this becomes 7C. Now I can go ahead and combine like terms. Let's just separate this with an arrow. The C squared, you always want your squared term to come first, which is C squared. Then you want your other two variable terms to come next, because remember x squared plus bx plus c, you want to keep that form. So the two other terms with a variable are the 3c and the 7c. So 3 add 7 is 10. That makes 10c. It's not c squared because you're not multiplying. You see the difference? We're just adding the like terms here. We're done with multiplying. So these two c's together do not become a c squared because they're just being added. This one was already squared. And that leaves us with the 21. C squared plus 10c equals 21. If you look back at the example on page 159 for a second, I'll put this back in a minute, but here we have it. C add 3 multiplied by C add 7 equals C squared plus 10C add 21. Now, we can take this and take it apart again. This is called the FOIL method. The second concept of this lesson, and that's used for multiplication. Second concept of this lesson is factoring, which is breaking polynomials down. So we are going to factor c squared plus 10c add 21. And I can already tell you what the answer is going to be. It's here. It's going to be c plus 3 and c plus 7. But, so basically we're doing the reverse of what we just did. Here we multiplied to get this. Now we want to break it down again to get back to this. It's like multiplying and then dividing. So if you do 4 times 4 is 16, then you can do 16 divided by 4 to get back to 4. Or if you do 9 times 4 is 36, 36 divided by 4 is 9. You're breaking it back down to the basics. That's what factoring is breaking back down to the basics of where you came from. So let's take this fabulous polynomial, c squared plus 10c add 21. Now I can start by setting up brackets. Now the fact that I have a c squared here tells me that I'm going to need a c in each bracket, because c times c is c squared. So I need a c here and a c here. Now I am looking for the factors of 21, and I want to know which of the factors of 21 will add up to make 10. So let's take the number 21. You have 1 and 21. 1 times 21 is 21. 2 is not there, but 3 goes together with 7 to be factors of 21. Let's see if there's any more. There's 4, 5, 6, and then we're back to, or once you're at 7, you know you're finished. There aren't any more. These are the 4 factors. The 2 are out of the 4 factors of 21. Which of these 2 factors that multiply to make 21 also add up to make 10? The 3 and the 7. 3 add 7 is 10. 21 add 1 is 22. So we're looking for the 3 and the 7. They multiply to make 21 and they add up to make 10. That's what you'll always be looking for. So we go c plus 3 and c plus 7. You might see negatives come into play sometimes, but we'll get to those later. We're not going to worry about those for now. So there's our first example. Let's get on to some other ones then. So we're going to continue. We're going to look at page 161. And we're going to do a whole bunch of different foiling examples from 161. So we're going to have, on 161 example 1, we're going to have A and B that we're going to do. X minus 4 multiplied by X add 2. 8 minus B multiplied by 3 minus B. And then C add 3 multiplied by C minus 7. And 5 minus S multiplied by 9 minus S. So let's work our way through these one at a time. Grab a fresh page, fresh sheet, and label this page 161. And all of these examples will be FOIL. Front, outside, inside, left over. So your first one, X minus 4 and X plus 2. Front, X times X, X squared. Outside, negative 4 times 2 times positive 2, that's negative 8. Because a negative times a positive is a negative, remember? Inside, the minus 4 and X becomes minus 4X. The leftover terms are the X and the 2. 2X. They're both positive, so that stays positive. Put your X squared first. The 2 terms with the X variable that's not squared. Negative 4 add 2 equals 2. X minus 8. 8 minus B and 3 minus B. The front terms this time are 8 and 3. 24. The outside terms are the 2 B's. This is a negative times a negative. It becomes a positive. So plus B squared. Inside, negative B and the 3. Negative 3B. Leftover terms are the 8 and the negative B. Negative 8B. B squared. Negative 3, take away 8, is negative 11B. Add 24. There we go. C plus 3 multiplied by C minus 7. C times C, C squared, those are front terms. Outside, 3 times negative 7, it's negative 21. Inside, 3 times C is 3C. The leftover terms are the C and the negative 7, negative 7C. C squared, 3C take away 7C. 3 take away 7 is negative 4. C squared take away 4C, and then the 21, minus 21. There's that one. Five minus S multiplied by 9 minus S. Front terms are the 5 and the 9. 45. Outside terms are, again, the two S's. Similar to a question that we had with the B's before. So a negative times a negative is a positive, and there's two S's multiplied, S squared. The negative S and the 9 are on the inside. Negative 9S. Leftover terms are the 5 and the negative S. Negative 5S. S squared, take these two. Negative 9, take away 5, will give us a negative 14. S, add the 45 that's left over. There was a plus here, and it wasn't negative here either, so we keep it a plus, keep it a positive. 21 up here, if you look, was a negative. So then it stayed negative over here. Okay. As we transition our way into factoring, let's start with this example. I'm going to go with a fresh page just so that I can get all the factoring onto one page. I think that's better that way. Got this copied down. So we're going to do some factoring. V squared, add 12V, add 20. Starting off with a nice factoring example that does not have any negatives. I know there's a V squared, so I need a V here and a V here. The V's could also be at the end, as you know by now, but it doesn't actually matter. So now we want the factors of 20, and we want to find which two of those factors are going to add up to 12. So I'm going to have 1 and 20. After a while you can do this without making the list. You could just do it in your head. I'm going to have 3 and 4. I'm going to have 6 and 2. And 10 and 2. Sorry, I didn't mean to write these two. 1 and 20, 5 and 4, 10 and 2. I was doing factors of 12 there for a second. Sorry, because I was looking at the 12 here and it messed me up. So 1 and 20, 5 and 4, 10 and 2. Which of these add up to make 12? Obviously the 10 and the 2. V plus 2, V plus 10. The order here doesn't matter. I could have put the 10 here and the 2 here. Makes no difference. In case you're wondering about that. It'll still multiply out to give you V squared plus 12V plus 20 when you FOIL it. Now, we're going to do a bunch of factoring examples. I'm going to pull all of them from page 163. Okay? So all of the ones I'm going to do next are examples from page 163. X squared minus 2x minus 8. Set up my two brackets. What do I need in there in the first place? 2 x's. I'm looking for factors of negative 8. That will add up to make negative 2. So I could have negative 1 and 8. Remember, one has to be negative, one has to be positive to get a negative 8. And negative 4 and 2. And I believe that is all of them for 8. Now, what do I need? Which one of these will add up to? It's obviously not the negative 1 and the 8. But if I look at negative 4 add negative 2, that gives me a negative 2, does it not? Yes, it does. Negative 4 add 2 is negative 2. X minus 4 and x plus 2. And by the way, in this case, it'd be important to, and it shouldn't be x minus 2 and x plus 4 because that would give you a positive 2. So in this case, the 4 needs to be negative and the 2 needs to be positive. As far as the negative 8 is concerned, it doesn't matter which one's negative, but as far as the negative 2 is concerned where you're adding, it does matter. The 4 needs to be negative, the 2 needs to be positive in order for this to be a negative 2. So that's one of the little ways that negatives come into play here. So we're going to have z squared minus 12z add 35. Bracket, bracket. Couple of z's in the brackets, eh? zz. Okay, factors of 35. Well, 1 and 35. And the only other ones I know of are 5 and 7. Now, the 12 is a negative, but the 35 is a positive. How do I do this? I make them both negative. Z minus 5, Z minus 7. Negative 5 at negative 7 is negative 12. Negative 5 times negative 7, positive 35. So, x squared minus 8x plus 7. Whoa, factors of 7. It's a prime number. It's got 1 and 7. That's it. So those two numbers had better be able to make 8, and of course they do, except it's a negative 8. So x minus 1, x minus 7. I would say that's about the easiest one of the day so far. A squared plus 7a minus 18. Was that a plus there? Yeah. Plus 7a minus 18. Bracket, bracket, bracket. A squared, a. Factors of negative 18. Well, there's negative 1 and 18. There's negative 2 and 9. There's negative 3 and 6. 4, 5, 6. We don't need to list 6 and 9 again. I think that's all of them. So, you don't have to list all of them. I just do it this way for clarity. But as soon as you find the pair that adds up to this middle number, you're good. In this case, it's negative 2 and 9. Because negative 2 add 9 will be negative 7. And again, the 9 can't be your negative, because then it would be negative 7 instead of positive. So a plus 9, a minus 2. 9 times negative 2 make negative 18. 9 add negative 2 makes 7. Hope that it makes sense and gives you clarity. I hope. Good. Let us then proceed with several more examples. I'm pulling these from 164 and 165, and I'm going to do 4 more examples. Some of these are a slight change from what we've done so far, but I promise only a slight change. Factoring on 164 and 165. So here we have minus 24 minus 5d plus d squared. Now this is what I would do. I would change the order. I'd put the d squared first, then I do minus 5d, then I would do minus 24. It's my way of doing it. I find it to be the easiest way. Then I set up my brackets just like before with the 2 d's to make the d squared. Then I look at my factors of 24, and it's a negative 24. So negative 1 and 24, negative 2 and 12, negative 3 and 8, negative 4 and 6, 8, 9, 10, 12, 12, 12. I think that's all of them. So which of these will make me a negative 5? Well, it has to be the 3 and the 8. I listed the 3 as a negative, but you can see which one's going to have to be the negative to make a negative 5. Negative 3 add 8 gives me a positive 5. So d minus 8, d plus 3. You gotta be, don't assume that the way you listed your factors to find the correct one is going to be necessarily correct for doing the question. In this case, the sign needed to be reversed. And again, after a while, like I could do this question without making the list of factors, but I'll keep doing it. But the way you do it when you do your homework is entirely up to you. Add 7m plus m squared. Taking a bit of a pause here, having a little drink of water and so on, and then it will continue. All right. Again, let's change the order. M squared first, plus 7m minus 30. It just makes it easier. You could factor this, but it's easier to do it in the order that you've been working with all along. So when you get a question that's not in the form that we began this lesson with, x squared, and then the x, and then the number without a variable. As soon as you get one that's not in that order, my advice would be to turn it into that order and make your job easier. Bracket, bracket, m, m. Let's list those factors of 30 now. Negative 30, I should specify. Negative 30 and 1, negative 2 and 15, negative 3 and 10, negative 5 and 6. I think that's all of them. So you can see where you need to zoom in on to get the 7. The 3 and the 10, it's a positive 7. So my sign can stay the same this time. M minus 3, M plus 10. Okay, now our final concept for today. It'll be slightly different, but honestly not that much different and not more difficult really. But I'll do a squiggly line here to kind of separate. So I'm taking this from page 165. Minus 4t squared minus 16t add 128. Well, we don't have the t squared by itself. So then, okay, what happens now? Our regular factoring method seems to be not working the way we'd like it to. Well, we can factor out a 4. That negative 4 that you see here can be factored out. Negative 4 can be factored out. And I'll show you how that works. You set up a bracket, a long bracket, put the negative 4 on the outside. What's going to be on the inside here? The t squared, because the 4 has been factored out. So just the t squared. Now we have it next, we have negative 16t. Well, 4 times what is 16? That would be 4, right? So we need a plus 4, because negative times positive equals negative, plus 4t. And now we have the 128. Now we need to find the number that 4 multiplies by to make 128. I'm just going to take my calculator here. And I'm just going to do it the lazy way, 128 divided by 4. 32. So in the brackets, this is a negative, the 28 is a positive. I need minus 32. So now I have t squared plus 4t minus 32. Now I bring down the negative 4 and I set up my two brackets, t and t, and now I'm looking for factors of 32, just the same as before. So negative 1 and 32, negative 2 and 16, negative 4 and 8, Sandozola, 5, 6, 7, 8, I think so. So which of these two of these will add up to give me a positive 4? I zoom in here. Negative 4 add 8 will make 4. So minus 4 plus 8. So my final answer is t minus 4, t plus 8, with a negative 4 factored out. That's how you do it when you get a leading coefficient that's not just a single letter. Then you can't factor it until you factor out that whole number. And what you do when you can't factor out, that's another story for another lesson, which will be coming up. Not going to do that one today. So, in fact, we're not even going to do that one this week. This is a heavy recording, and it's going to be with only 4 school days, which means really only 2 math days. We're just going to have the one recording for this first week back. So let's do one more example here. Again from minus 5h squared minus 20h plus 60. Well, who can I factor out? Obviously the minus 5, which for my first term in the brackets is going to leave me with an h squared. 5 times what is 20? 4. And how do I get a negative 20 in there? I do a plus 4, because the 5 is already a negative and I factored it out. Plus 4h. 5 times what is 60? Don't need my calculator for that one, although you might. It's 12. And so the 5 is a negative, the 60 is a positive, so the 12 has to be a negative, because negative times negative is positive. All right, so I factored out the 5. I have h squared at 4h minus 12. So whatever you factor out has to be factored out from each individual number. Just a little baby step further, right? H. I need factors of 12. I was doing those earlier by accident. Now I get to actually do them. Minus 1 and 12. Minus 2 and 6. Minus 3 and 4. I believe that's all of them. Now, the question is simply, which ones add up to make the plus 4 in the middle? Negative 2 and 6. Minus 2 plus 6. Negative 2 at 6 equals positive 4. H minus 2 and H plus 6. Your homework will be found on... I've given you so many examples today. You're probably feeling a little flooded right about now. But homework. Page 166 to 167. Numbers. 5, 9, 11, and 21. 166, 167, 5, 9, 11, 21. Let's have a look at all those, shall we? Before we shut down this thing. 5. Don't worry about algebra tiles. We're not using those at all. Number 5 on page 166, you use the FOIL method to do those. Front, outside, inside, left, over, 4 questions. Okay. Tons of examples for you to look at. If you do this right away, it'll be that much easier. If you push it off, you'll forget. You gotta do this so that it sticks. If you don't do it right away, then you end up having to rewatch the class. Gotta do it so it sticks. Sticks. Number 9. Once again, it's the FOIL method. Front, outside, inside, left, over, 4 questions. Number 11 is factoring. Here's your first one. X squared plus 10x plus 24. I can already tell you what it is. It's x plus 6 and x plus 4. Because 4 times 6 make 24 and 4 and 6 make 10. Yes. 4 and 6. 4 times 6 make 24. And 4 and add 6 make 10. Should I do another one? M squared plus 10m at 16. Factors of 16. 8 times 2. 8 add 2 makes 10. M add 8. And M add 2. Done. Chuck. You are only to factor, you are not to check by expanding. Number 11, kolla homos is factored. Okay? Don't worry about checking by expanding. What that means is you would take x plus 4 and x plus 6 and you would FOIL them again. But don't. Just factor for number 11. Just factor. 21. These are now questions where you're going to be pulling out a whole number. So, all 6 of those. Again, I'm only giving you the one recording this week. So you should be fine. Here you can factor out a 4, right? Then you're going to have y squared. You're going to have minus 5y, because 4 times 5 is 20, and 4 times what is 56? 56. Is it 12? No. 13. It's 14. So then you're going to have minus, so y squared minus 5 minus 14. Then you're going to factor that down. If you have any questions about number 21, let me know. But you do need to do all 6 of them, and all 8 for number 11, and all 4 for number 9, and all 4 for number 5. You gotta get the practice on this one, people. Especially for the next concept coming up. And this lesson is now, this recording is now over 40 minutes. It is time to close it, and it is time for you to get those practice questions done and ask questions if you need any help. Hand them in to be checked over to be sure you're on the right track. Good luck. Again, this is going to be the only math recording for this week, the week of January 4 to 8.